Hello, welcome to the presentation. Today, in this presentation, we will evaluate two complex buildings. The modern complex building is Burj Khalifa, which is located in United Arab Emirates. The traditional complex building is Sagrada Familia, which is located in Spain. At 828 meters, the 200 plus story Burj Khalifa has 160 habitable levels, the most of any building in the world. The tower was started in 2010. Burj Khalifa utilized a record-breaking 330,000 cubic meters of concrete, 39,000 tons of steel reinforcement, 103,000 square meters of glass, and 50,500 square meters of stainless steel. The tower took 22 million man-hours to build. The primary design concept of the tower is the form of an indigenous desert flower named Hymenocallis, an organic form with triaxial geometry and cyberlink growth that can be easily seen in the final design. Additionally, traditional Islamic forms were also utilized to enrich the tower's design and to incorporate visual references to the culture and history of the surrounding region. The Y-shaped plan, formed by having three separate wings connected to a central core. As the tower rises, one wing at each tier sits back in a spiraling pattern, further emphasizing its height. The Y-shaped plan is ideal for residential and hotel usage, in that it allows the maximum views without overlooking a neighboring unit. The wings contain the residential units and hotel guest rooms, with the central core housing all the elevating and mechanical closets. The Y-shaped design helps to reduce the impact of wind on the tower. Each tier of the building steps back in a spiral pattern up the building. This pattern deflects the wind around the structure and prevents it from forming organized whirlpools of air current, and that would cause the damage of the building. The Y shape provides a stable structure and helps to maximize the view. The tower superstructure of Burj Khalifa is designed as an all-reinforced concrete building with high-performance concrete from the foundation level to level 156, and is topped with a structural steel brace frame from level 156 to the highest point of the tower. The structure of Burj Khalifa was designed to behave like a giant column with a cross-sectional shape that is a reflection of the building massing and profile. The main structural system for this megastructure has been named a buttressed core. This new structural system allows for a dramatic increase in height. The structural system consists of a three-winged structure fixed to a strong hexagonal central core. Each wing is buttressed to the other to provide a highly stable system. The central core provides the torsional resistance for the building, while the wing provides the shear resistance and increased moment of inertia. Within the wings, corridor walls extend from the hexagonal core to almost the end of the wing. The hotel and residential floor framing system of the tower consists of 200 mm to 300 mm two-way reinforced concrete flat plate slabs, spanning approximately 9 meters between the exterior columns and the interior core wall. The floor framing system at the tips of the tower floor consists of a 225 mm to 250 mm two-way reinforced concrete flat plate system. The Burj Khalifa has taken the prefabrication construction to a new level. The key to speed is a new technology called jump forming. The process starts at the bottom of the building. Steel workers collected steel cages that will become the backbone for the floors and walls to the building. The crane lifts the steel cages up and slid them into special rooms called jump forms. Then goes the concrete, and 12 hours later, when the concrete hardens, the form gets ready for the jump. Hydraulic position push the form up, leaving the concrete block behind. It takes only 2 hours for the form to move up to the next level, where the process starts all over again. This way, the Burj Khalifa is cast in layer by layer. High-performance concrete is utilized for the tower, with high modulus concrete specified for the columns and walls. The concrete mix was designed to provide low permeability and high durability concrete. One of the most challenging concrete design issues was ensuring the pumpability of the concrete to reach the world record heights of the tower, which required that concrete be pumped in a single stage with over 600 meters. 4 separate basic mixes were developed to enable reduced pumping pressure as the building gets higher. The maximum allowable aggregate size decreased with building height, requiring no more than 10 mm aggregate above level 127. A horizontal pumping trial was conducted before to the start of the superstructure construction in order to ensure the pumpability of the concrete mixes. The final pumping system utilized on site uses Bottomister pumps. 3 major pumps were placed at the ground level. Pumping line 1 situated at the center core, with pumping lines 2, 3, and 4 at the south, west, and east wings of the core. An additional pumping line 5 was located at the center core area for emergency use. Most of the concrete has been pumped directly to the highest concrete elevation. Making a super tall building stand up in the desert sand requires special measures. The Burj Dubai have poor rock, it is very weak, so they went 50 meters down deep into the rock in order to get enough of rocks and support that structure. Any big hole in these rocks will cave in immediately. To stop this from happening, the engineers fill the boreholes with a viscous polymer slurry, which pushes the groundwater and rock to the edge of the hole and keep it open. The slurry polymer is denser than water, but lighter than concrete. The tower raft is supported by 194 piles. The piles are 1.5 meter in diameter and approximately 50 meters long, with a capacity of 3,000 tons each. The solid reinforced concrete raft is 3.7 meters thick and was poured utilizing 12,500 cubic meters. The raft was constructed in 4 separate pours, 3 wings, and 3 center core. The concrete mix combined 40% fly ash and a water cement ratio of 0.34. The Burj Khalifa will be able to accommodate 55,000 people. To cope with the numbers, the Burj Khalifa has 57 different elevators. Some reach over 35 km an hour and rise 120 floors in under 50 seconds. The biggest lifts carry up to 46 passengers. Fire safety was given great importance during the design phase of Burj Khalifa. The concrete surrounds all stairs. The building has services elevator with a capacity of 5,500 kilograms and will be the world's tallest surfaces elevator. Some elevators are allowed to control during fire or emergency situation. Since it's not possible for people to walk down 160 floors in case of emergency, refuge areas are provided every 30 floors. The concrete is naturally fire resistant, but the tower is expected to be nearly twice as tall as the Twin Towers. So how do people get out in an emergency? The answer is they don't. The building contains 9 very special refuge rooms, built from layers of reinforced concrete and fireproof sheeting the walls of these rooms, withstand the heat of a fire for 2 hours. Each room has a special supply of air pumped through fire-resistant pipe, and fireproof doors stop smoke from leaking in. In the refuge room, residents can seek shelter from a fire until emergency services bring it under control. There is one of these rooms above every 30 floors, which should allow residents to reach them without too much effort. Refuge rooms are a brilliant idea, but even the safest place in the world is no good if the access route is blocked by smoke. The building has an early warning system that protects it all the time. If the fire activates a smoke detector, a heat sensor, or water sprinkler, a network of high-powered fans kick in the fans force clean, cool air through fire-resistant ducts into the building. The fresh air pushes the smoke out of the stairs and keeps the place clear. The outside paint is coated with a thin layer of metal. Like sunscreen, the metal coating deflects ultraviolet radiation that would otherwise heat up the building. But the sunscreen is useless against the infrared that radiates from the hot desert sand. So the inner paint is with a thin layer of silver that keeps the heat rays out. Over 30,000 glass panels, enough to cover 17 football fields, will protect the Burj Khalifa from the scorching heat. The Sagrada Familia, designed by Spanish architect Antoni Gaudí. His works are inspired by his religious faith and love of natural organic forms instead of straight line. The objective of Sagrada Familia design is to tell the story of the Jesus Christ's life. The Sagrada Familia is built on a cruciform plan, It has 5 naves, which are reduced to 3 at the transept. It is 90 meters long and 60 meters wide. The temple is made up of a central nave flanked by aisles and transepts forming a Latin cross. At the head of the cross is a semicircular apse. The temple of the Sagrada Familia is surrounded by a rectangular cloister with 12 towers symbolizing the apostles, 95 to 120 meters high, crowning the two existing and another projected facades. Besides, 6 big towers will be built on top of the vaults. The central tower, measuring 170 meters, represents Jesus Christ and is surrounded by the 4 135 meters tall Evangelist towers and the 138 meters tower of the Virgin Mary. The towers are situated in the center of the transept and on top of the apse. The naves on Sagrada Familia don't need buttresses. That means the aesthetics load stability in its design. In Sagrada Familia, there are 3 different facades: the Nativity facade, Passion facade, and the Glory facade. Each facade requires massive amount of details that take a long time to construct. The Nativity facade never fails to surprise the visitor because the detail of the decoration. Other feature from the facade is that it has 3 portals that have different sculpture based on their symbology. These portals called the Portal of Hope, the Portal of Faith, and the Portal of Charity. Moreover, there are 4 towers in this facade. Each represents to a specific scene. Gaudi wanted to make the Nativity facade as the best face of the church. The Passion facade is contrast to the Joy of Nativity facade. It mainly demonstrates the passion of Jesus, the struggle, and the death. The Passion facade also has 3 entrances. However, it's not as decorated as Nativity facade. It consists of geometrically simple forms. The plain and rigid appearance of the facade shows an angular form, which purpose is to bring a dramatic touch of the death of Jesus. There are 3 levels in this facade. The 3rd facade is the Glory facade. That is still in the process of construction. It began in 2002 and is still ongoing. This facade will become the main entrance once it's finished. It is the largest facade compared to the other 2 facades. There will be a porch with 7 columns. However, the decoration and the detail of the exterior have made the facade into a very time-consuming process. This has largely contributed to the slow construction process. One of the most important innovations of the Sagrada Familia are its rule services, which will comprise the greater part of its elements from windows to rooms. The designer did combine geometrical forms chosen for their formal, structural, luminous, acoustic, and constructive qualities. Many of these surfaces are rolled, which makes the construction easier. He assigned one of these forms to each type of the elements that make up the naves. He used hyperboloids for the openings of the windows and the walls. With paraboloids, he created linking surface on the walls, roofs, and columns of the Passion facade. Gaudi designed a new space for the inside of the temple with a new architecture based on root and other geometries. Gaudi's approach was to rationalize the structure by enhancing different aspects of Gothic architecture. These structures and branching internal columns, designed according to anti-funicular load balances. In addition, the buttresses in their role of communicating vertical loads to the foundations. The central naves are characterized by columns in the form of trees and a ceiling that is formed like sunflowers. It is remarkable that Gaudi did in fact invent a new geometric structure for his columns. Gaudi developed a column with a variable transversal shape. It increases gradually its number of sides, passing slowly to an almost circular section and eventually to a circle. The family of structural columns include also intermediate columns that in turn form the base for smaller columns. It is necessary to split the weight of the bolt into separate forces. The approach resulted in these ceilings being designed as hyperboloids constructed out of reinforced concrete, a material that can take on any shape and would enable Gaudi to design the roof as unified structural elements. As we have seen, the building materials and system that used in the construction of the naves include stone columns and windows, reinforced concrete walls, flat brick walls, stone roofs, and glass. A structure of reinforced concrete is the material already used by Gaudi on the Nativity facade, which he had also proposed for the vault of the naves. Begins in the foundations and finishes in the interior support structure. The vaults at 30 meters are generally built of concrete. The hyperbolic vaults at 45 meters or higher are being built using ceramic materials. Gaudi designs and builds the Nativity facade towers out of reinforced concrete. Furthermore, the external pieces of the top 17 meters of the spires, which are covered in Murano glass, are crafted from prefabricated reinforced concrete pieces made in the on-site workshop. The prefabricated pieces that top these spires are over 3 meters tall and are affixed to the building at a height of over 100 meters. This means that they had to be built from a material that could resist the tension that could arise both during handling and in the final arrangements. The Sagrada Familia has a pile foundation. The piles under the main nave are estimated to have a depth of approximately 20 meters. For the leaning columns, Gaudi again took inspiration from trees. The base of those columns spread out as paraboloids, just as the roots at the base of the tree trunk spread out. It transferred the load more efficiently to the ground. Now look at the shape of cylinder towers. The lower part is made up of 12 vertical stone ribs, whose purpose is to make the spires stable and more wind resistant, while the horizontal openings mark the rhythm of their climb and distribute the sound of 85 tubular bells that will ring out over Barcelona when the building has been completed. The stained glass windows are an essential feature of the Sagrada Familia. Gaudí gave them the same importance as the architecture of the carving. The glass is sitting in lead strips in order to play with the shape and the rhythm to achieve a symphony of light and color. That is why the windows on the lower part are brightly colored, whereas those in the upper half are lighter. In the central nave, the windows are a combination of colorless glass of different texture, which makes the geometry of the vaulted ceiling stand out. The next few years, we will see the final stage completed in the construction of Sagrada Familia. The sacristies will be finished as will the cloister around the church. The Tower of Mary will also be completed. The main facade, the glory facade, will be built. The Tower of Jesus will reach the height of 170 meters. This will make it Sagrada Familia one of the highest buildings in Barcelona. There are multiple similarities between the two buildings. Burj Khalifa is the tallest building in the world, and Sagrada Familia is the tallest building in Barcelona. Both of them using the concrete as a main material. That's because the concrete can be formed on any design easily, and it is good for fire protection of the building. In addition, both of them using bias foundation to resist the load of the building. However, the main design of Burj Khalifa and Sagrada Familia inspired from the nature and religions. To compare between Burj Khalifa and Sagrada Familia, it's important to mention the modern technology of construction in Burj Khalifa, which include jump forming and concrete pumping. Both of them help to speed the construction process, while the Sagrada Familia is still in construction process since 150 years ago. In addition, the designer using different methods to deal with wind problem. In Burj Khalifa, they try to distribute the wind, while Sagrada Familia, the designer wants to deal with wind to transfer the sound from the building to the city. Furthermore, the Burj Khalifa located in the hot weather, so they should to protect the building from the outside temperature, while Sagrada Familia using the color glass to play with the light. However, the structural system of Sagrada Familia using the rolled surfaces, while Burj Khalifa depend on the main core with 3 wings.